had long hair. It's kind of working, I guess. Wow. Hey, Grade Nines. Yeah, so I've just spent the last minute of my life rubbing a balloon all over my hair. It was incredible. And what we observed today is something that deals with static electricity. And that is, as we move into our next unit on electricity, our first topic relates to this idea of static electricity, and that's what we're talking about today. Okay, so materials such as the balloon and my hair on my head are materials where electrons can move. And so what we saw happen just now was that electrons moved from my hair into the balloon, and then there was an imbalance of charges. And so these materials, they carried an electric charge. And through that process of that balloon moving across my head, charges transferred. They moved from one material to the other, and as a result, static electricity was built up because of this electron transfer. And so when we get this imbalance of positive charge and negative charge, things can attract. And you guys can still see the balloon will stay stuck to the board. That's due to this imbalance of charge. Now, static typically, it means not moving. Something is still. And that's not really true in this case because electrons are still in motion. They're still in motion in this balloon. They're still in motion in my hair and every other type of material in this world. So they're not exactly still, but mostly what we're going for is this imbalance. And so I guess one thing we can say is that these electrons are, more of them are located in one area than the other, and that's how this imbalance can occur. And so in grade 9, there's two types of electricity that we want to talk about: static electricity, the topic that we're talking about today. The second type, and this is what the rest of this unit will focus on, is current electricity. And yeah. Okay, so just now, you guys saw those electrons. Well, you didn't see them because I didn't see them either, but they moved from the balloon. We can see their effects, but we can't see them. So they moved from my hair to the balloon when they were in contact, and as a result, there were more negative charges in the balloon than there normally would be found because those electrons moved from my hair to the balloon. So there was a loss of electrons here, a gain of electrons here, and so what we notice is that they're kind of, electricity and magnetism are related. And so earlier in the video you might have seen my hair move back and forth because the balloon was negatively charged, my hair was positively charged, and so the balloon was able to attract my hair, even defying gravity. So our law of charges, and maybe you remember this from a previous grade, but if my charges are the same, those two materials are going to repel. If they're different, those two materials will attract. There'll be an attractive force between those. Okay, so when sometimes when we go to the park, my kids will slide down the slide, and many times when I go to catch them, there'll be some type of spark given off. Right when and sometimes when they're coming down the slide, they'll be like, "No, don't catch us," because they're afraid of that spark. Well, not really afraid, but it just happens sometimes. And the same thing happens if you've ever walked across a carpet and you touch a doorknob, and sometimes you can even see that little spark go from your finger to the doorknob. And that's because your feet are picking up those electrons as you walk across, and then those electrons, when they touch something conductive, they release. They jump. And so, yeah, why does that happen? Why are the electrons jumping when you're about to touch the doorknob? It comes down to this. Some materials are insulators and some materials are conductors. And so if a material is an insulator, it's holding on to those electrons tightly. They don't move around. So they're not, an insulator is a type of material that will not give away its electrons and not, let's say, accept them very easily. This is exactly opposite to conductors, which will easily give up electrons and accept them, and electrons can flow through these materials. And yeah, so they're very different. And you might remember from our unit in chemistry, most metals are conductors and our non-metals are good insulators. So when that spark comes from your finger and hits the doorknob, that's called an electrical discharge, and we get this neutralization reaction happening. So preferably the chemicals in our bodies and the metal doorknob and the metal door frame as well, they would rather be electrically neutral, and things will always, electrons will always move in such a way that the atoms that make up those materials can become neutral. And so, and if we think about, if we do get a buildup of electrons, and if there's more electrons in a material than normal, all those electrons, there's that when that overall negative charge is created, all those electrons are repelling each other. So they don't all want to be together, and they like their space. And so they will discharge for that material to become neutral if they can. And we also talked about that miniature lightning bolt that sometimes we can see in an electrical discharge. Sometimes if we get electrical discharge when we don't want it to happen, it can be costly. It can cause damage. It can cause damage to circuit boards and electrical equipment, and even humans as well. So we do something called grounding. So the Earth is a very good acceptor of excess electrons, and so when possible and when needed, we can allow those electrons to flow into the Earth. So maybe an example is the lightning rod on a house or building. So this will be a big metal pole going from the top of the building to the bottom, such that if it gets struck by lightning, all the electrons will flow through that piece of metal back into the ground where they can be easily accepted. It's also good to ground some of our electrical appliances, especially the expensive ones, because they can also be damaged by static electricity and current electricity, I guess, too. But you'll notice that when you plug something in, there's that third prong, and that helps that appliance be grounded. So it'll be attached to some type of grounding wire as well. Okay, that's all I have for you today on static electricity. And I will post some questions and an assignment for you on Google Classroom. Take care and have a great day.